Welcome to qnawire.
In 48, we have 5 meson, and in it file the reaction 5 mesons into copper and copper minus. So it has a strangeness 0. And we want to first find energy of K plus meson, kinetic energy. This K does not denotes kinetic, it's not the particle name. And then part B, we want to suggest a reason why this reaction has not been observed. Why not? Part C, to suggest a reason, kappa becomes K plus pi minus, and K plus mu minus is not observed. In part B, we're explaining why K plus, K minus, and pi naught is observed. It's not observed, there must be something that is not conserved. So let us first try to work out the first part. In this reaction, the total energy released is the energy equivalent of the mass decrease. So the mass decreased is delta M is mass of phi minus mass of K plus minus mass of K minus. So we look up table 44.3. This is going to be, actually let's try to look at mass equivalent, because MC is going to be then just M. This is going to be B 1 0.4 MeV is the energy for I, and then 2 kappa antiparticle in the particle itself has the same energy, so times 493.7 MeV. This gives us an energy of 32 MeV. Then only looking for the so this is going to be the kinetic energy that is released, but this is a kinetic energy that is released to both particles. Now we only have one particle, so one particle's amount of kinetic energy is going to be 16.0 MeV. And then we look at part B. Why does this not occur? And the reason is that if we look at the mass on the right-hand side, the mass of 2 kappa plus the mass of pi naught is going to be 1122 MeV. This previously we have the pi, the mass 1019. We have 1122. It is larger, so that is to say, the mass of the decay product is greater than the mass of the parent product. So this reaction is energetically is unfavorable unless you give, and if you have two particles, maybe you can give them a huge kinetic energy and ask them to collide. But right now you only have one particle, and this one particle is not going to spontaneously decay into a more unstable state. So, and then we look at part C. Part C says, why does these two occur or not occur? Let's look at the first one. So this is something that we need to check the strangeness. We know that the strangeness of pi is 0. And then if only have K plus and K minus, K plus has a strangeness of 1, K minus, this is strangeness, it has 0, K minus has a strangeness of 1. So the strangeness, it was 0 before and after the reaction. But then if we look at this, we know that mu and pion will have a strangeness of 0. So in this case, we have a of 0 before the reaction, but for both reactions, we will have a strangeness of positive 1 after the reaction. So strangeness conservation is violated. That's what reactions have observed.